What's this game behind me? It's actually the solution to a math problem we're going to talk about today. So this is Let's Learn Real Analysis on TikTok Part 10. So today in class, before our quiz, we wrote a proof that the sequence -1 to the n, which just alternates -1, 1, -1, we want to show it doesn't converge to anything. Now to actually write everything out, whoa, you need all this stuff. But let's watch that movie again and see what's going on. The dots are our terms 1 and -1, and this purple strip represents how close we want these terms to be to our limit, which is in the middle of that strip. You can see that if the strip is reasonably small, no matter where you put the limit, there's no way it's going to contain eventually all the terms after some point. By the way, super proud of my students. They did great on today's quiz. But here's how we would write this problem up in a formal proof. And so we're just going to be direct about it. We're going to say take any number, and I'm going to show that our sequence, -1, 1, etc., does not converge to that number L. Now in previous videos, we talked about how converging to a number is a very technical condition involving the number epsilon and something called November. And we're going to say, look, even if you let epsilon be 0.5, you're not going to be able to do it. And so if we were able to find some November, then that would mean that every term past November would have to be pretty close within 0.5 of our limit. Now, because our sequence alternates between 1 and -1, after November, there are definitely going to be terms that are 1 and there are going to be some terms that are -1. But now look, that means that one of those terms that's 1, well, that has to be within a distance of 0.5 of our limit. But that term that's -1 also has to be within a distance of 0.5 of our limit. Very importantly, that limit's the same, right? Its limit is the limit, right? It's the number L. Now, if you unravel what these inequalities mean, you think about the biggest and the smallest that L could be, you get some contradictory information. The stuff on the left is saying that L has to be a positive number. The stuff on the right says that L, in fact, has to be a negative number. This cannot happen, and that shows that there's just no limit L that's going to work. This completes our very first proof in the series of a sequence that does not converge to anything. Next week, we're going to learn some basic properties about convergent sequences, enlarge our toolkit so we don't always have to get out the epsilons when we're writing our proofs. Coming soon are things like bounded sequences, Cauchy sequences, subsequences, Bolzano-Weierstrass. It's going to be lots of fun. Subscribe and follow if you're interested in learning more about this stuff.